Okay, we had started the notes for section 3.1 where we were starting to take a look at how to actually graph functions by hand. And we had kind of discussed this idea here of what critical values are. We said critical values are these really, really important places on the graph where the x value causes the nature of the graph to change. And so those could be things like maxes or mins, so places on the graph where there's a peak or there's a valley. They could also be corner points or asymptotes, so it could be like a jagged corner point of sorts, or if there is like an asymptote at that x value, that would be a critical value. Now, where do we find these maxes, mins, corner points, asymptotes? They're located any place your derivative is either equal to 0 or where your derivative is undefined. And so that's why when we go through this process, we had said we were kind of skipping this first step here for the moment. Our first step is we need to actually take the derivative of our function, and once we have the derivative, what we're wanting to do next is we're wanting to actually set the derivative equal to 0 and factor, okay? And it is in that factoring process, that once we have it factored, then we can set each factor equal to 0, and that's when we kind of uncover where those critical values are. And so we had walked through one full example in the notes of that process there of how to graph by hand, and we had started this example, and I believe that we got as far as we had found the critical values, and we were just beginning making a sign diagram. And so I'd like to finish this example with you and just do one more example to kind of solidify how to do this process here for you. So, quick refresher, we actually begin with step number 2. If you have this page, you might find it helpful because when you see me referencing the steps, I'm going to be referencing steps 2 through 7 here from this list. Okay, so we're going to start with step number 2, which is to take the derivative, which I believe we did that together. Okay, so the derivative we said was 3x squared minus 12. Make sure when you guys do that, your next thing in the factoring process is to always check for a GCF. Okay, so you can see we removed a 3. We were left with a difference of 2 squares. We broke that down into an x plus 2 and an x minus 2. I didn't need to do anything with this 3 because there wasn't an x with it. If there was an x with that, I would have had to have also set 3x equal to 0. That would have created a third critical value. But in this case, we just set each of these factors equal to 0, and that uncovered that our two critical values were at -2 and then at +2. Okay, and that brings us to the sign diagram here. Okay, the sign diagram is step number 4. Okay, step number 4 here. And what you do on the sign diagram is you take the two critical values, you kind of picture this horizontal line here that you're going to draw as a number line. You want to start with the smallest critical value, put a dotted vertical line, and underneath the vertical line say that when you substitute that critical value into the derivative, you get a 0. Okay. Then we're also going to put another dotted line for our other critical value and say the same thing. Now you can have more than 2 critical values. If you have 3 critical values, then you would draw another dotted vertical line here. Okay? All right, so I've got essentially 3 different sections here for my derivative. And you'll notice I put a star here next to where my derivative was completely factored. And I'm going to highlight here, I have 1, 2, 3 different factors in my derivative. Okay, so when I'm setting up my sign diagram, each of these intervals, I'm going to be multiplying 3 signs together. Okay, now as I look closer at my 3 signs, the one I highlighted in orange here, that's a 3. That does not have an x in it at all. So that is going to be locked in as a positive. Okay, that's always going to be a positive 3. But these other 2 factors have x's in them. So this is where you have to choose what's called a test value. Okay, you're going to choose a test value, and this dotted vertical line represents where -2 is located on the number line. So you have to pick some number that would fall to the left of -2. Okay, let's just say -3. Okay, so I'm going to plug -3 into this second factor for the x, and if I take -3 and I add a 2 to it, I'm going to get back a -1. So I'm going to report that I would get a negative for this middle factor if I'm over here in this section. Okay, now I'm also going to plug a -3 into this third factor, the yellow factor here. Okay, if I plug a -3 in here and subtract 2 from it, I'm going to get a -5. So that is also going to be negative. All right, so then I'm going to look at this and I'm going to say if I take a positive times a negative, overall that's going to result in a positive. Okay, now what that's telling you is that's telling you what the slope is for this section of your graph, all the sections that are smaller than -2. So I'm going to make a note here that my derivative is greater than 0. That means it's positive. And underneath the line, I'm going to draw a little section, a ray, that shows a positive slope. It's leaning upward. Okay. Underneath, where I said that at -2, the derivative is 0, remember, if my slope is 0, how that should look is my tangent line should be completely flat and horizontal. So you want to draw a flat horizontal line right here. Okay, now I'm going to move to this middle section. Now this is in between the numbers -2 and +2. So I want to pick some test value between -2 and +2. And again, anytime you have the chance to choose 0, that's always a really good choice here. So I'm going to go ahead and pick 0 as my test value. I'm going to come up here and look at my green factor here. If I plug a 0 in, I'm going to be left with a +2. So that means my middle factor is a positive. If I plug 0 into my yellow factor up here, I'm going to be left with a -2. So that means my third factor is going to be negative. Okay, so a positive times a positive times a negative overall means my slope in this middle interval is negative. My slope, my derivative is less than 0. So I'm going to draw an arrow going down. Okay, now I'm back directly underneath right here where I said the slope is 0. So that's where I'm drawing another flat horizontal line. Try to draw them so the ends kind of butt right up against each other. That way it's kind of creating the shape of the graph as you're making this sign diagram. Okay, we have one more section left. Over here on this section, it represents numbers that are greater than 2. So you can pick any number you like as long as it's a number bigger than 2. I'm just going to pick 3. And I'm going to plug 3 into the green factor. 3 plus 2, that's going to return a positive. And then I'm going to plug 3 into my yellow factor here, 3 minus 2. That's also going to return a positive. So 3 positives together make a positive. My slope is now positive. Now, if you're wondering, is it always just going to alternate back and forth, positive, negative? That is not always true, okay? It can be positive on one side, positive on the other side, okay? And we'll learn more about that a little bit in this section and definitely more in the next section here. Okay, it is very important when you guys are making these sign diagrams. See all these little tiny labels that I have all over this graph here? You need all of these labels on your sign diagram. If you check your answer in the back of the book, it's not as detailed as this, so make sure you're looking at your notes and you're including all of these labels, even these little =0 right down here where your critical values are. Okay, there's a couple more things that need to be placed on this sign diagram, and we'll do that as we work our way through step number 5. Okay, step number 5, I'm just going to flip back here so we can see that step number 5 is when we actually find the critical points, like the y values that go with those x values by plugging the critical values into the original function. Okay, very important that you're plugging those into the original function here. Okay, so let's go back to, I'll do this off to the side here, step number 5. Our two critical values were -2 and +2. These are not being plugged into the derivative, but rather they're being plugged back into this original function up there. If you plug -2 in to the original, you get 24 back out, and if you plug +2 in, you get -8 back out. Now, this is what also needs to be placed on your sign diagram. So directly underneath where the -2 is, right here, okay, you're going to place the point -2, 24. Now look at the way the arrows go. They go up, flat down. That means this point, negative 224, would be considered to be a max. So I want you to add that label to the sign diagram. Okay, over here you're going to add that this is the point 2, negative 8. Again, look at the arrows. It goes down, flat, and then up. Label, this is the last thing you need to put on the sign diagram. That is a minimum. Okay. Okay, that brings us to step number 6, which is where we find the y-intercept. The y-intercept is found by substituting a 0 into the original. If we plug a 0 into the original, you can see we're going to be left with the number 8. So our y-intercept is at the point 0, 8. Okay. All right, and then finally we are to step number 7, which is where we're ready to actually sketch the graph here. And sketching the graph is going to be a combination of looking at the sign diagram and also plotting the y-intercept. Now I would look at your points here, the points you have on your sign diagram as well as your y-intercept, to help gauge what you should count by on the x-axis and what you should count by on the y-axis. As I look at the x values, negative 2, positive 2, and 0, those don't feel like they're really that large. So I'm just going to count by ones on the x-axis. But if I look at my y values, I see 24, negative 8, positive 8. I'm going to go ahead and count by 8s on the y-axis. All right, so there's my labels for the y-axis. Okay, the next thing you want to do is you want to put those points, this point here, and the y-intercept, put all 3 of those on your graph. As you plot them, next to the point, label the coordinates and label what that point is. Max, min, y-intercept. Okay, so we're going to label 2, negative 8. We said that was a min. And then 0, 8. We said that was a y-intercept. So now I have my 3 points here. Okay, the next thing for me to do is then look at these arrows, look at the intervals. To the left of this max, I should be drawing it going up, and then on the other side of that max, I should be drawing going down. So I'm going to go up. As I'm drawing it going down, I want to run through that y-intercept. When I come down and hit the min of 2, negative 8 on the other side, I'm going to go back up again. Okay. Pretty cool that we were able to graph that using calculus and not needing to use our graphing feature on our calculator whatsoever. Okay. Now, do keep in mind that for the homework assignment from before, from I think the first part of this notes, the first several problems were just asking you to find the critical values. So you're essentially only doing steps 2 and 3. You got to be able to factor correctly. You set those factors that have x's in them equal to 0. You just report the critical values, you're done. I believe it was the last 3 problems that had you solve by graphing. That's where you'll need to do all 7 of these steps. So we're going to do one last example here. On the next page, we're not going to do anything with this first derivative test till we get to the next couple sections here. So let's just jump down. This will be our last example we'll look at together here. Example B. We'll kind of try to run through these steps a little bit quicker here, but we're going to be doing all 7 steps here for this, okay? Okay, now I guess we do start with step number 2, which is to take the derivative here. Okay, so the derivative for this is going to be negative 4x cubed plus 12x squared. Okay, step number 3 involves us finding the critical values where we take our derivative. We want to set that derivative equal to 0. Okay, now anytime we do factoring, we always want to check for a GCF first. Okay, it's looking like both these terms have a 4. And they both have an x squared. Always a good idea to make your lead coefficient positive. So I'm going to factor out a negative 4x squared. Okay. If I factor out a negative 4x squared, I'm going to leave behind an x there. I'm going to leave behind a minus 3 there. Okay. Now, if you look closely, you'll see we have 2 factors, negative 4x squared, x minus 3. Okay. Now, of these 2 factors, you'll notice the ones that have x's in them, they both actually have x's in them. So I want to set each of those factors, negative 4x squared equal to 0 and x minus 3 equal to 0. Okay, the x minus 3 gives me positive 3. when I solve this one, I'm going to divide by -4, which I still have 0, and then I'm going to take the square root of 0, which still is 0. So my two critical values are 0 and 3. Okay, now if this problem was just asking me to find the critical values, that is where I would stop. Okay, I am going to put a little star, though, next to this step where I have my derivative factored, because I'm going to need to go back to that for my sign diagram. Okay, my sign diagram is step number 4. I'm going to draw a nice horizontal line. Okay, I have two critical values. I want to start with the smaller one, the 0, put a dotted vertical line, label that is where the derivative, f prime of 0, equals 0. And over here, another spot where the derivative equals 0 is when we plug a 3 in. Okay, those are our two critical values, go in those spots there. Okay, I'm actually going to look at my derivative as really being comprised of 3 factors. I think this might make the sign diagram easier. So you'll notice I'm separating the -4, which you wouldn't have to do. I'm separating that as its own separate factor from this x squared. Okay, and the reason I'm going to do that, you'll see here, I'm going to put 3 places here for my 3 factors. Okay, now I'm going to go ahead and highlight just so this is a little bit easier. Whoops. We'll call the -4 my yellow factor, x squared the green factor, and x minus 3 the blue factor. Well, if I separate the -4, that doesn't have an x with it anymore. That's going to always be a negative. So I'm just going to lock that in. It's a little hard to see here. My first set of parentheses, I'm making that a negative. Okay, now I want you to take a close look, though, at the x squared. I know normally we do pick numbers, test values in each of the intervals, but I want you to think about this. If something is squared, whether you plug in a positive for the x and square it, or whether you plug in a negative for the x and square it, it's always going to come back as a positive. So I don't need to waste time picking a number. I know that if this factor is just something squared, I know it's always going to come back as a positive. So I'm going to lock in that middle green factor as always being positive. Okay? Now, the one factor that could change depending on what I plug in for x is this blue factor here. So now I actually do have to choose a number. Remember, this vertical dotted line represents where x is 0. So if I'm picking a number in this interval, I need to choose a number smaller than 0. So I'm going to pick -1. If I plug -1 in for this x and then subtract 3 from it, that's going to be a -4. Okay, so that means in this interval, a negative times a positive times a negative makes overall my derivative a positive. So I'm going to draw this arrow going up, and then it's going to be flat right underneath where the dotted vertical line is. Okay, now I'm going to come to the middle interval. I need to pick a number between 0 and 3. Okay, so I'm going to choose the number +1. I'm going to plug +1 into my blue factor here. +1 minus 3, that would be a negative. So I'm going to have a negative here. Now, if I take a negative times a positive times a negative, that's going to come back as a positive. So now I'm going up again on the other side. I'm flat here. Okay, and I have one last one. I need to choose some number to the right of 3. So I'm going to pick 4. If I plug 4 into this factor here, 4 minus 3, that's going to come back as a positive for that factor. So now I'm doing a negative times a positive times a negative. That overall is going to return a negative. So my slope, oops, I forgot to label here. This should be f prime is greater than 0 there, and here should be less than 0, drawing this down. Okay, so here's an example of where it wasn't a max and it wasn't a min. Okay, this point, when it's not a max and not a min, it has a special name, which we'll learn in the next section. If it's not the top of a hill or the bottom of a valley, you don't have to identify what it is at this point. Okay, all right, let's go on to step number 5, which is where we find the critical points. We take each of these two critical values. Remember, we are plugging those into the original function. So they're going into this original function. 0 plugged in, whoops, sorry. A 0 plugged in returns the number -20. And a 3 plugged in returns a 7. So let's add those final pieces to our sign diagram. I have no label for that, but for 3, 7, I'm definitely calling that a max because it was going up, flat, and down. Okay. Step number 6 is my y-intercept. Step number 6, my y-intercept, me plugging 0 into the original. Well, it kind of feels like I already did that because 0 was a critical value. So that's my y-intercept, okay? So I'm going to look at my points here, 0, 3, 0. I'm not going to count by anything other than just ones on the x-axis, but my y values are -20, 7, again, -20. I'm going to go ahead and just count by tens on the y-axis, okay? We really only have 2 points to put on here. 0, -20, which I guess I can label that as a y-intercept, and then 3, 7, I'm going to label that as a max. Okay. Past that, I'm going to look at my sign diagram to guide me through how to sketch. Okay. To the left of this point, 0, 20, I need to be having a positive slope, a slope that's going upward to this point, but then on the other side of it, I also need it to be going up, okay? So something maybe like this, it's going up, runs through it, still going up, but then when I hit there, the other side, I'm going back down again, okay? Just a couple of things. If you have a few questions on the homework from the first part of the notes, I just want to look at a couple things. If you don't have questions, you can go ahead and stop the video right now. That's fine. But I did just want to look at example number 9 with you, just to make sure that you were okay with the derivative and the critical values on that. For number 9 on the homework, the problem started out like this, and this problem only asked you to find the critical values. This exponent was a 4 here, okay? So this is going to require us to do the chain rule to take the derivative, okay? So when we do the derivative, the chain rule says pull the exponent in front, leave everything on the inside the same, subtract 1 off of the exponent, and then multiply by the derivative of the inside, which technically would be a 2. Okay, you should combine the 4 and the 2 together and make that an 8. Okay, so here's how your derivative looks. Now, here's the advantage of this. This is already factored. Like, it is already in its factored form. Essentially, what this is saying is you have an 8, and then you have 1, 2, you have 3 factors that are all 2x minus 6, 2x minus 6, 2x minus 6. And you don't have to write those out 3 times like that. But if you think about what the critical values are, it's supposed to be taking each of your factors that have x's in them. This 8 does not have an x in it. Now, if these factors are duplicated, you only need to take one of those factors, set it equal to 0, solve for x. There is only one critical value for this, and the critical value is the number 3. Okay, and I think that's all that this problem asked you to do. But this was a weird problem because once you found the derivative, the form of the derivative was sort of already in its factored version there. Okay, if you are struggling at all with factoring these problems, please make sure that you reach out to me, especially the problems that are asking you to graph them by hand, because if you cannot get past the step of how to factor, then you can't find the critical values. You can't move forward with the problem, okay? So make sure that you reach out if you have questions.